Welcome to Chapter 7 of Writing Logically and Thinking Critically. This is that extra long chapter that I warned you about on deductive and inductive argument. So in this chapter, we're going to cover how to identify deductive and inductive reasoning, how to determine the validity and soundness of a deductive argument, how to evaluate the probability of conclusions reached by inductive reasoning, and how to distinguish between causation and correlation. So let's take a look at necessity versus probability. In a deductive argument, the conclusion will follow by necessity from the premise if the method of reasoning is valid. So let's take a look at this example. The first premise, all men are mortal. The second premise, Socrates is a man. And then the conclusion, therefore Socrates is mortal. In this case, the premises of a deductive argument contain all the information needed for the conclusion itself. However, inductive arguments are different. In an inductive argument, the conclusion can follow only with some degree of probability. Let's take a look at the logic of this chicken. He has fed me today. He has fed me this day. He has fed me this day too. He has fed me yet another day. Therefore, he will feed me tomorrow. The conclusion of an inductive argument goes beyond the premises. And in this case, if tomorrow is slaughter day, the chicken is sadly mistaken. In deductive argument, the inference usually moves from a generalization to a particular specific instance or example that fits the generalization. Let's look at this example. All students who complete this course successfully will fulfill the critical thinking requirement. Jane has completed this course successfully. Therefore, Jane has fulfilled the critical thinking requirement. So the first premise is a broad general statement. The second premise is something more specific, which leads us by necessity to the conclusion of the argument. In an inductive argument, the inference usually moves from a series of specific instances to a generalization. Here's the example we have from our book. Droughts have been more frequent in some areas. Skin cancers related to ultraviolet rays have been increasing. The tree line is moving north about 40 meters a year. Polar ice has been melting more rapidly than in the past. Oceans have been rising at measurable annual rates around the globe. So therefore, clearly global warming is upon us. So now that we have a broad overview of the differences between deductive and inductive reasoning, let's look more specifically at each case. We'll start with deductive reasoning. So let's take a look at the idea of a class. Good reasoning in general often depends on seeing relationships between classes. And in logic, a class is all of the individual things that share a common feature or property. For example, all of you are students. That's one class. Some of you are male and some of you are female. Those are two different classes. Some of you are wearing pajamas right now. Some of you are wearing sneakers. Those are two more classes. And then we can start to have overlap relationships where certain members of the males and certain number of the females are both wearing pajamas, for example. As I just mentioned, there are three possible relationships you can have with classes. There is the inclusion, exclusion, and overlap relationship, and we'll look at each one of these in depth. The first relationship we'll look at is the relationship of inclusion. Inclusion is one class is included in another if every member of one class is a member of the other class. If you look at the diagram, it illustrates that all human beings belong to the class of mortals. Therefore, the circle, humans, is nested inside the larger circle of mortals. The next type of relationship is that of exclusion. This is where one class excludes another if they share no members. For example, the class of fox and the class of cats are completely separate. No cat is ever a fox, and no fox is ever a cat. The last type of class relationship is the relationship of overlap. Overlap is when one class overlaps with the other because both have at least one member in common. Let's take a look at the diagram below. You have a circle that comprises professors at BCC and another circle that comprises professors who like red. And where you see the circles overlap are all the professors at BCC who also like the color red. So next, let's take a look at class logic and the syllogism. A categorical syllogism is a deductive argument composed of three classes. Such an argument has two premises and one conclusion. And here's our example from our book. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. We can break down the categorical syllogism into the subject and the predicate parts. The subject is the part of the sentence about which something is being asserted, and the predicate includes everything being asserted about the subject. If the conclusion follows of necessity, inescapably from the premises, as it does in the syllogism about Socrates, then it is a valid argument. Validity has a very precise meaning. It means that the conclusion follows of necessity from the premises, the form of the argument is correct, and the line of reasoning conforms to the rules of logic. Premises must also be true or acceptable and reasonable to believe. If the premises are not, then we have another problem. When we talk about the acceptability or the soundness of an argument, two requirements must be met. First, the structure of the argument must be valid. That is, the conclusion must follow of necessity from the premises. And two, the premises must also be acceptable. A deductive argument whose premises are acceptable and whose structure is valid is a sound argument, or a successful deductive argument. We have to be careful, though, about the fallacy of guilt by association, which assumes that if two classes share one quality, they share all qualities, which of course is not necessarily the case. So how can we determine the soundness of an argument? Well, there are some steps that you can use to get there. The first one is identify the three classes, subject and predicate in the first premise, subject in the second premise. Represent that relationship between the three classes by drawing circle diagrams. Compare the circle diagram to the conclusion. If they match, the structure of the argument is valid. If they don't, then the structure is invalid. Then you have to determine the acceptability of the premises. Are they reasonable to believe? If the structure is valid and the premise is acceptable, the argument is sound. If both criteria are not met, however, the argument is unsound. Let's take a look at another type of argument called a hypothetical argument. Hypothetical or conditional arguments are concerned not with classes, but with conditions. The condition is called the antecedent, and the consequence is called, very uncreatively, consequent. Here's an example. If Maria drops the glass, it will break. Maria dropped the glass, therefore the glass broke. In this case, the antecedent has been affirmed. Let's look at another valid pattern from our poor, clumsy friend Maria. Another pattern is one in which the minor premise denies the consequence. If Maria drops the glass, it will break. It did not break, therefore Maria did not drop it. There are also invalid hypothetical argument patterns. To deny the antecedent or affirm the consequent leads to invalidity. For example, if Maria drops the glass, it will break. Maria did not drop the glass, therefore the glass did not break. However, there are many other ways for a glass to break, therefore this argument is invalid. To affirm the consequent will also produce an invalid argument. If Maria drops the glass, it will break. It broke, therefore Maria dropped it. The glass broke, but Maria may not have been the cause, therefore the argument is invalid. So let's review the patterns of hypothetical arguments. In this slide, you see that the first two patterns create valid arguments. If A, then B, A, therefore B, and if A, then B, not B, therefore not A. However, the next two patterns of hypothetical argument are invalid. If A, then B, not A, therefore not B. If A, then B, B, therefore A. So let's talk about the concept of necessary and sufficient conditions. A necessary condition is a condition without which something cannot happen. Fire cannot occur without oxygen, but oxygen alone cannot start a fire. Therefore, oxygen is a necessary but not sufficient condition. The last piece of our exploration of deductive reasoning are hypothetical chains. Now, in order for a hypothetical chain argument to be valid, we must accept the truth of all the claims being made. And here is the pattern. If A, then B. If B, then C. If C, then D. If D, then E. If A, therefore E. And there was a very good example of that in your book. So the next section of this lecture concerns inductive reasoning. You might want to take a break at this point because I know that the first part of this presentation was quite long. Unlike deductive argument, inductive argument deals primarily with probabilities. The certainty guaranteed when deductive argument is validly reasoned from acceptable premises cannot be assumed in an inductive argument. Therefore, the terms most appropriate for inductive argument are strong, weak, reliable, or unreliable, as opposed to sound and valid. In fact, statistical generalizations are best characterized as predictions, as claims about the distribution of a projected property in a given group or target population. A sample is a part of the target population. We make a prediction, an inference, about the unknown on the basis of the known. On the basis of our observations of the sample, we make a generalization about all of the population, including the part we have not observed closely. When dealing with inductive reasoning, we may start by noting specific instances and from them make general inferences, or we may begin with a general idea and seek specific examples or data to support it. With inductive arguments, we accept a conclusion with varying degrees of probability, and we must be willing to live with at least a fraction of uncertainty, which is very different from deductive arguments. In order for statistical generalizations to be useful, the size must be adequate, the proportion of those in the sample must be sufficient to reflect the total size of the target population. The sample must be representative, therefore randomly selected and spread across the population to include some of each class that's included in the population. A sample is a subclass included in the larger class of the target population. We still must use caution not to jump to a hasty generalization. We must use our critical thinking faculties, however, when dealing with surveys and statistics. Because surveys and statistics suggest an authority they may not warrant, we must read them critically rather than accept them without question. And we must not mistake correlation for causation. Just because there seems to be a link doesn't necessarily mean there is one. To determine causation, researchers must conduct randomized controlled studies, and such studies are lengthy and difficult to complete. And we must always consider the source of the survey. We must look for any hidden agendas or conflict of interest. For example, a survey that indicates sugar is healthy for you should not have been funded by the National Sugar Council. And finally, here are some ways we can determine if a survey is valid. Is the sample representative of the target population? Is it large enough? How long did the study last? Was the study random and controlled, or was it observational? Does the media's report of the survey seem fair and reasonable? Does the survey establish causation or correlation? And who wrote or published or called your attention to the survey? Are they impartial, or do they have a hidden agenda or conflict of interest, like our previous example of the Sugar Council? Is the survey cited in advertising or in another context in which the motive is to sell you something? Once you have determined these questions, you can then decide if the survey is valid and useful.